So there's a two-dimensional collision here. We're not told anything about it being elastic, so let's draw a diagram and see what's going on. So car 1 has a mass of 2,500 kilograms. It's moving east. Okay, I mean, we're sticking with our usual cardinal directions here, north, east, south, and west, and we'll make the eastern direction positive and the northern direction positive for this problem. It's moving east with an initial speed of 55 meters per second. And we have car 2, which is 3,500 kilograms, moving north with an unknown speed v2I. And the two cars stick together after the collision and move off together, M1 plus M2, at an angle of 51 degrees north of east. We don't know the speed, and we want to know what's the original speed of car 2, v2I. So, we've really got two unknowns here, VF and V2I, and we've got two equations, which is the X and Y conservation of momentum. Remember that in a collision, momentum is conserved, so I can say that the initial momentum of car 1 plus the initial momentum of car 2 is equal to the final momentum of car 1 plus the final momentum of car 2. But I can't just plug in 2,500 times 55, plus 3,500 times V2I is equal to 6,000 times VF. You can't do that because with vectors, you can't add them up in that way. You have to add them up by components, right? Back when we did A plus B equals C, right? You don't take the magnitude of A plus the magnitude of B and call it the magnitude of C. Vectors don't work that way. So you have to break them into components. So let's start with the X component. Alright, M1 is 2,500, and V1I, the X component is 55. The Y component will be 0. The X component of V2I, well, V2I points in the plus Y direction here, so it has no X component. And then this side, well, actually this side can be rewritten like that, right? Because V1F and V2F, they move together, so this is 6,000 times the X component of VF, right? So that's VF cosine 51. And the Y component will be VF sine 51. So VF cosine 51. Alright, and then for the Y component, let's see, we have 2,500 times 0. The Y component of V1I is 0, right? V1I points in the positive X direction. It has no Y component. The Y component of V2I is just V2I, because V2I, whatever it is, it points in the Y direction. And then this side, of course, can be rewritten again as M1 plus M2 times VFY. So that's 6,000 times VF sine 51. Okay, so I've got two equations and two unknowns. My two unknowns are V2I and VF. So let me solve the top equation for VF. I get VF is equal to 2,500 times 55 divided by 6,000 cosine 51. So that works out to be 36.4 meters per second. I'm going to take that value for VF, that's the final velocity of the combined wreck after the collision, I'm going to put it right there. So that gives me 3,500 V2I is equal to 6,000 times 36.4 sine 51. So if I solve for V2I, I get 49 meters per second. There's my answer.